Welcome to this session, and this is chapter number 3. Chapter number 3 we are starting, that is nothing but fast Fourier transform. Fast Fourier transform. In the previous chapter, we have discussed discrete Fourier transform. Discrete Fourier transform. Now, in DFT, if suppose a signal is given, x of n is dt signal given, then the DFT of it, that is represented as x of k. This is called as DFT of x of n. Then for calculation of DFT, there are various methods. One is by using formula. X of k is equal to summation n star from 0 to n minus 1 x of n w n dash to n k n minus 1. So this is the formula for calculation of DFT. This is the first method by which you can calculate the DFT. In second method, you are using the matrix for DFT calculation, that is 1 1 1 1 1 minus j minus 1 j 1 minus 1 1 minus 1 1 j minus 1 minus j. So this is the matrix, and by multiplying the matrix with x values, you are getting the answer for DFT. So we have discussed all those methods, by formula method, by matrix method. Similarly, we have discussed IDFT, inverse discrete Fourier transform. Now in case of FFT, fast Fourier transform, this is called as fast Fourier transform. We are finding the DFT only through the FFT, but through the method which is faster than DFT methods. This is the faster method for calculation of DFT. So it is, hence it is called as fast Fourier transform. Fast Fourier transform. In case of DFT, you are multiplying the numbers, you are adding the numbers, means there is a complex number multiplication, there is a complex number addition, there is a real number addition, real number multiplication. Means the calculations required more, and hence the computer which performs the DFT, it requires more time for calculation purpose. Here only we are discussing 4-point DFT, correct? This is the matrix for 4-point. 8-point, there is 8 by 8 matrix. 16-point, there is a 16 by 16 matrix, and for each multiplication you have to multiply with the some number, then you have to add it. So this task is huge. And that task can be reduced by using the fast Fourier transform. In the previous sessions, we have discussed only 4-point DFT. But we will discuss later by 8-point DFT, in 8-point DFT also. So in 8-point DFT, the matrix is 8 by 8, and the numbers are also in 0.707 minus j707 minus 0.707 plus j 0.707. So it has the numbers in fractions also, the numbers are in complex terms also, so that multiplication will take huge time, lots of time, and that is reduced by using fast Fourier transform. So in fast Fourier transform, whatever answer you will get, the same answer you will get from the DFT methods. Means in earlier, if suppose the x of n is 1 2 3 4, then by using DFT you are calculating the x of k, the answer, that is 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So this is the DFT of this x of n. If you apply fast Fourier transform, then also you will get the same answer. There is no issue, but the method is faster. The FFT, it is divided into two types. The FFT is divided into two types, that is DIT FFT and DIF FFT. DIT FFT means decimation in time. Fast Fourier transform. fast Fourier transform. And DIP means decimation in frequency fast Fourier transform. So those are the two divisions or different types of FFT fast Fourier transform. Decimation in time. Decimation means division. You are dividing, if you are dividing into time in terms of time, then that is called as decimation in time. And if it is in frequency, that is called as decimation in frequency. Now here are the fast Fourier transform. Those are divided into two types, that is DIT FFT and DIF FFT. Decimation in time fast Fourier transform and decimation in frequency fast Fourier transform. Now we are going to discuss decimation in time, that is decimation in time fast Fourier transform. Fast Fourier transform. So it is in this DIT FFT, you are using the butterfly diagram. And through that butterfly diagram, you are going to calculate the DFT. Now I will take suppose 2-point DFT. For a 2-point DFT, the butterfly diagram is such type of diagram you will have. It is x of 0, x of 1, because there are two inputs and outputs are x of 0 and x of 1, and this is minus 1. So arrows are there. So how this butterfly diagram, you know how this butterfly will look. Suppose this is nothing but butterfly, how this butterfly will look. So there is a similarity between this graph and that graph, hence it is called as butterfly diagram. Now how the calculation will be done, this x of 0 will be taken. If suppose this is the point where you have to perform the addition, so x of 0 will come, and from here it is x of 1 will come, that is x of 1. Hence what is the capital X of 0? X of 0 plus x of 1. Now x of 1, this x of 0 will be as it is positive, so x of 0, and this x of 1 it is multiplied by minus 1, so minus x of 1. So this is nothing but what we called it as a FFT. This is 2-point FFT flow graph. This is called as butterfly diagram. Now suppose we are taking example, find 2-point FFT of x of n is equal to 1 and 3 using DIT FFT flow graph. Okay, using DIT FFT flow graph. So what you will do, you will draw the flow graph. This is arrows shows there is a summation at this location, this is minus 1. Then it will be x of 0 and x of 1. This is capital X of 0 and capital X of 1. Now what is the value from this x of 0, x of n? Write down x of 0. X of 0 is equal to 1 and x of 1 is equal to 3. So put that values, x of 0 is 1 and x of 1 is 3. Then 3 will come here, 3, and this is 1. 1 plus 3, answer is 4. Now this 1 will come here and this is nothing but minus 3. So 1 minus 3, answer is minus 2. So that finally x of k is 4 comma minus 2. So that is the answer we have for 2-point FFT. Similarly, we can go with the 4-point flow graph, DIT FFT flow graph. This is a 4-point DIT FFT flow graph. 4-point means there are 4 inputs, there are 4 outputs. And this is nothing but 2-point FFT, this is 2-point FFT, and this is 4-point. So together it is called as 4-point DIT FFT flow graph. In case of DIT FFT flow graph, the inputs are in out of order. Those are the inputs, and those are the outputs. You must remember this flow graph, output. So in 4-point, what are the inputs? X of 0, x of 1, small x of 1, x of 2, and x of 3 are the inputs, correct? And what are the outputs after we are getting this capital X of 0, capital X of 1, capital X of 2, and capital X of 3? Means DFT, we are getting the answer in the FFT. So in 4-point DIT FFT flow graph, those are the inputs. Inputs you can't write x of 0, x of 1, x of 2, x of 3. Inputs are in out of order and outputs in order. So you will get the output like this. First value will be x of 0. Second value will be x of 1. Third value will be x of 2. And fourth value will be x of 3. But inputs you cannot write in order. Those are in out of order. So you can write, you have x of 0 as the input, then x of 2. Second is x of 2 because it is divided as even and odd based on even and odd terms. Then x of 1 and x of 2, x of 3. Understood? So you must remember this flow graph, and this is nothing but -1. This is -1. Here is the -1. Here is the -1. And here you have to multiply by -j. Multiply by -j. So this is nothing but the 4-point DIT FFT flow graph. DIT FFT flow graph. X of 0, x of 2, x of 1, x of 3, x of 0, x of 1, x of 2, x of 3. Now how you can remember this? How you can remember those terms? It is very simple. We know that 1, 0, 1, 2, and 3. As there are 4 numbers, means 0 to 3, we can represent them by using the 2 bits. How this 0 will be represented? 0, 0. 1 will be represented 0, 1. 2 will be represented 1, 0. 3 will be represented 1, 1. Now reverse the bits. Reverse bits 0, 0. This will become 1, 0. This will become 0, 1. And this will become 1, 1. So what is the binary of it? 0, 2. Then it is 1, and this is 3. So out order means 0, 2, 1, 3, and in order means 0, 1, 2, 3. So that you can easily write 0, 2, 1, 3. So you can remember it, and output are x of 0, x of 1, x of 2, x of 3. This is the flow graph. You have to remember the flow graph. Now we'll solve the problem based on 4-point DIT FFT flow graph. In decimation in time, you are dividing in time. This is the time domain representation, small x. This is frequency domain. We are dividing in time, as we have divided x of 0 based on the even and odd like this, x of 0, x of 2, x of 1, x of 3. We have divided into time. Now we'll solve the example. See it carefully. Find DFT of x of n is equal to 3, 2, 1, 3 using DIT FFT flow graph. So you have to draw this flow graph. From x of n, what is the x of 0? First of all, write down x of 0. X of 0 is 3. What is x of 1? X of 1 is 2. X of 2 is 1, and x of 3 is 3. Correct? First of all, write down x of 0, x of 1, x of 2, x of 3. The values as a 3, 2, 1, and 3. Now, after writing it, draw the flow graph. This is the flow graph where the 4 inputs, you will have the 4 outputs. Write down the outputs will have in order. So x of 0, x of 1, x of 2, x of 3. Outputs in order. And what about inputs? Inputs are out of order. So x of 0, small x of 2, then x of 1, then x of 3. And all other remaining you have to write. This -1 means whatever quantity coming from that line, it will be multiplied by -1. This is multiplied by -1. Here it is -1. Here it is -1. And in between it is multiplied by -j. Okay. Now write down the numbers. What is x of 0? It is 3. What is x of 2? X of 2 is 1. X of 1 is 2. And x of 3 is 3. Correct? X of 3 is 3. Now do the addition at this location. You have to perform addition. 3 will come here, 3, and this is 1 plus 1 means what? Answer is 4. Then 3 will come, 3, and this 1 is multiplied by -1, so it is -1. Answer is 2. Similarly, 3 will come from this side, 2 will come from this side 2 plus 3, answer is 5, and this 2 will come to this 3 is a minus 3, so minus 1. Then minus 1 multiplied by minus j, answer will be j. Answer will be j. Now again the same procedure, 4, this 4 will come from this end and 5 will come, so 4 plus 5, answer is 9. Answer is 9. Then this 2 will come 2 and this is plus j. So answer is equal to 2 plus j. Then it is 4, 5 is multiplied by minus 1, so it is minus 5. So answer is equal to minus 1. And last it is 2, j is multiplied by minus 1, so minus j. So answer is equal to 2 minus j. So we can write x of k is equal to 9, 2 plus j minus 1, 2 minus j. So this is the answer or DFT by using DIT FFT flow graph, using 4-point DIT FFT flow graph. So this is the fast Fourier transform. It is easy. We know the 4-point DFT is easy to calculate by using even matrix. But if you are going for calculation of DFT, 8-point DFT, it is very difficult to calculate. It will take some time. And in fast Fourier transform, you can save the calculation, or you can save the time, and you can easily calculate the answers. So this is nothing but what the specialty of FFT. So fast Fourier transform. In computers, whenever you are going to do any DFT calculation, the computer is using FFT algorithms, not DFT algorithms. They are using FFT algorithm for calculation or faster calculations. So this is nothing but 4-point DIT FFT flow graph. We will take one more example. Example number 2 we will take for calculation of 4-point DFT. Find FFT or 4-point FFT of x of n is equal to 1, 2, 3, 4 using DIT FFT flow graph. FFT flow graph. Now, whenever you are going to solve this example, you must read it carefully, whether the DFT is asked, whether FFT is asked, whether by using DIT FFT method is asked, or whether it is the actual matrix method is asked. So you must read the question carefully and then solve. So for 4-point FFT, x of n is given. So first of all, write down x of n. X of n is equal to what? 1, 2, 3, 4. After writing it, separate it. What is the x of 0? 1. X of 1 is 2. X of 2 is 3. And x of 3 is 4. Okay. After writing it, next is draw the flow graph. So 4 lines. 4 lines. Then the butterfly diagram, 2 point like this. Then this is connected to next. This is connected to next. This one is connected to here, and this is connected to this one. It is minus 1, minus 1. This is minus 1, minus 1. This is minus j. Okay, and it is x of 0, x of 2, x of 1, and x of 3. Then it is x of capital 0, x of 1, x of 2, and x of 3. Correct? Now put the values. X of 0 is 1, x of 2 is 3, x of 1 is 2, and x of 3 is 4. Now do the calculations. It is arrow, it is having the arrows. Arrows shows at that location you have to add, you have to calculate the summation. Okay, summation. Then 3 plus 1, 4. 1 minus 3 is minus 2. 2 plus 4, 6. 2 minus 4, that is minus 2. Okay. Then minus 2 multiplied minus j means 2j. Then 4 will be here. 4 plus 6, 10. then minus 2 plus 2j. Then next will be at this location 4 minus 6, that is minus 2, and then minus 2 minus 2j. This is 2j multiplied minus 2j. So we have this answer, x of k is equal to 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So answer we know, this is the answer, well known answer, and we have solved this by using 4-point FFT method, DIT FFT method, where x of k is 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So answer we got with this, and the same answer we got with the DFT matrix. So this is nothing but how DIT FFT flow graph we can use for calculation of FFT. Okay, so this is method how we can solve this. Now what will be the matrix for 8-point FFT? What will be the flow graph for 8-point FFT? So it is extended. Here you can see the extension. This is nothing but like a 2-point FFT. This is like a 4-point FFT. Now there is a 8-point FFT. Okay. So there are 8 lines input, and there are outputs. In case of FFT, a DIT FFT, output in even means output in order. So it will be x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7. Output are in order and input in out of order. So how you can write it? It is x of 0. Okay, x of 0. This is x of 1. Then it is x of 2. Then x of 3. Okay. Then it is x of 4. Then it is x of 5. Then x of 6. Then x of 7. So the input are in out of order and output is in order. This is nothing minus 1, minus 1, minus 1, minus 1. This is minus 1, minus 1, minus 1, minus 1. This is minus 1, minus 1, minus 1, minus 1. And we know that this is minus j, this is minus j. And here it is w8 raised to 0, w8 raised to 1, w8 raised to 2, w8 raised to 3. So this is the multiplication you have to take, and then finally you can calculate by using this 8-point DIT FFT flow graph. While before solving the example by 8-point DIT FFT, we can solve by matrix, means DFT we can solve, and then we can compare the values, then we can compare how much time it takes in case of DFT calculation and in case of DIT FFT calculation. And then only you can understand how the FFT is easy, how the FFT is fast. So this is nothing but till now we have come up to the 8-point DIT FFT flow graph. So once again you can see here the fast Fourier transform, it is a replica of discrete Fourier transform. Only the methods are changed. DFT we have solved by using the formula, also we have solved by using matrix. Then in fast Fourier transform there are two types, DIT FFT means decimation in time and decimation in frequency. Then we have the 2-point FFT flow graph. We have calculated 2-point FFT. This diagram is called as butterfly diagram. Then 4-point DIT FFT flow graph, you must remember it, where inputs are in out of order and outputs in order. Then minus 1, minus 1, minus 1, minus 1 and multiply by j minus j. Then we have calculated the DFT of x of n 3213 by using DIT FFT flow graph. Then we have solved one more problem for 1, 2, 3, 4. Then using DIT FFT flow graph we have solved it. Then this is the 8-point DIT FFT flow graph, where inputs are taken 8 inputs. You have to do the calculations. Now in case of 8-point, we will calculate w8 raised to 0, w8 raised to 1, w8 raised to 2, w8 raised to 3, and then we'll solve the problem based on this DIT FFT flow graph. So till now remember this flow graph. This is the 4-point flow graph, this is 2-point, and this is the 4-point flow graph. In next session, we will discuss how to calculate 8-point DFT, how to calculate 8-point DIT FFT. So that is nothing but next session we will discuss. Okay, so we'll stop here.